Hello guys and welcome. I hope that you're having a good day or good morning or good evening. My name is I play 4K, AK I play AK I play 16K or UHD King. During this video today I'm going to show you GTA4 running for the first time. This is going to be the world's first 16K resolution rendered in real time on a single Titan RTX video card and old school Xeon E5-2697 V2 CPU that was tweaked a little bit, and I'm going to explain to you how I tweaked it a little bit. So pretty much it was overclocked, and I know that it's impossible to overclock Xeon E5-2697 V2 CPU, but however, as you can see, I'm running 3.5 gigahertz or 3500 megahertz, and during this video I'm going to explain to you how I achieve that. In the end of this video it's going to be also the verification. I'm going to show you CPU Z, GPU Z, MSI Afterburner, couple IDA 64 benchmarks. So go ahead and smash that like button, grab yourself your favorite drink. Your favorite drink should be a green tea, green organic tea plus the lemon. This is the most healthier drink that you can have. Try to drink it for 2 months. Do not drink any soda, do not drink any alcohol. For 2 months, every day, if you're gonna drink organic green tea plus the lemon, you're gonna clean up your body and your soul and your brain, and you're gonna be very intellectual after 2 months if you're gonna drink organic green tea plus the lemon. Anyways, and healthy as well, with a lot of energy. Let's go ahead and get going. As you can see, this is the GTA4 benchmark built in the game without the shadow play recording. This is the result without the shadow play recording. Keep in mind that today I'm recording this video with the shadow play software by NVIDIA in real time. I'm coming in real time as well, and NVIDIA shadow play while it's recording consumes 4 FPS while it's recording this video, exact 4 FPS. So in the FPS counter, whatever you see during this video, just add 4 FPS. But in this particular benchmark right now, this is the actual raw FPS stats without the shadow play recording. And the shadow play was hacked during this video during the system RAM runtime debugging tool, and the width and height video container values was changed. It's easy to do, and it's outputting the video in 8K resolution. Okay, so I will try to go ahead and upload this video in 8K resolution as well, but this video will be multiple videos. I'm just going to cut it when I'm going to change the settings in the video. Why? Because when I'm running very high right now, everything maxed out, and sometimes it's crashing when I'm recording with NVIDIA shadow play when everything is maxed out. When I'm not recording, the game doesn't crash, and it also doesn't crash at any other presets. So I will try to go ahead and pretty much cut it out for you, and I'm going to put this video all together but without any editing, using the FFmpeg++ application that I'm developing right now. It's going to be a freeware application. It's going to be focused on the 8K resolution video encoding. Pretty much take 120 140 gigabyte 8K resolution video and turn it in 70 gigabyte video 8K resolution, almost with the same quality. It's hard to zoom in and see 2 frames and see the difference between the shadow play 140 gigabyte 8K resolution video versus my encoding compressed video 8K resolution through the FFmpeg++. The software that I'm developing is going to be a freeware, and it's going to be based on the FFmpeg DLLs, but it's going to be oriented for the users. It's going to be easy to use without any crazy commands knowledge. Alright guys, so this is what's going on. I'm going to go ahead and quit the benchmark, and it's going to run the game. And let's go ahead and get going. As you saw, the presets was the maximum possible visual preset. You want to keep your eye at the right top corner. It's self-explanatory. As you can see, FPS we want to keep as high as possible. Latency delay in milliseconds we want to keep as low as possible. Below 10 milliseconds latency delay is amazing gameplay results, below 20 milliseconds, very good gameplay results, playable status, and below 30 milliseconds, still playable, comfortable status, gameplay, and below 40 milliseconds, I would say it's so semi comfortable gameplay status, and above 40 milliseconds I call it benchable status and not playable status. Hopefully this makes sense. As you can see, VRAM utilization right now at almost 24,000 megabytes, but it's going to grow. The system RAM utilization is 11,900 megabytes. The total system RAM utilization can go all the way to 32,000 megabytes, but we will never reach that. It's a 4 sticks, 8 gigabytes each, DDR3 running in quad channel, and this Gigabyte X79 UG3 version 1.1 motherboard with F20 BIOS. Very crucial because it's not going to post. The CPU is top dog on the socket 2011 version 1, and it's not going to post on this motherboard if you're not going to use F20 BIOS. Keep that in mind. So if you're looking to set the CPU on this motherboard, you want to update the BIOS to F20 from Gigabyte website, March 19, 2013 or 2014, I believe, and then replace that i7 while you're flashing the BIOS, and then put the CPU. Otherwise it's not going to post. Right now I'm running, as you can see, very smart, and as again I'm going to explain to you in a second how I cheated and how I overclocked the CPU. Otherwise it could pretty much would be running almost 3000 megahertz or 3 gigahertz per each core, but I'm running 3.5 gigahertz, and as you can see I'm running only 3 core 3 threads, right? So pretty much with 3 core 3 threads, 3 physical cores, 3 physical threads, as again each core can accept virtual threads, like 100 virtual threads, it doesn't matter. So I cut it down, but 3 physical cores is not enough. 3 threads is not enough to run this game without, as you can see, it's a little bit freezing because it's overloading the CPU, so it needs a little bit more cores. So when I'm going to add additional 1 core, it's going to stop doing that, and I'm going to show you actually the next benchmark scenario will be with 4 cores. I'm going to reboot the system with 4 core 4 threads, and then we're going to do all benchmarks with 4 core 4 threads, but it's still going to be 4 core 4 threads, also very high. I'm going to show you, but pretty much I'm going to improve by 1 FPS. So when your CPU utilization right now, as you can see, below 40%, even 25%, when it's below 90% during your gameplay all the time, that means that you do not need to add additional cores. You're not going to benefit, you're not going to increase your FPS if you're gonna do it. And in our case, when the multiplier is locked on this enterprise CPU, I want to keep my auto turbo boost as high as possible, so it's going to unlock for us automatically the multiplier. That means that it's starting with 5 cores, when only 5 cores utilized and the rest is not utilized, and to be able to do so, the best way to disable those cores in the BIOS. And if your motherboard allows you to disable some cores and allows you to disable the hyper threading technology, this is exactly what you want to do. You want to be strategic, you want to know exactly how many cores game requires for you to run, and then disable them, and it's going to turbo boost it automatically, that multiplier, just like you overclocking yourself. But as again, you cannot overclock to the multiplier on this CPU, and even if I'm running the overclockable gaming motherboard, it's not possible. So at 5 cores it's going to use 31 multiplier, at 4 cores it's going to use 32 multiplier, at 3 cores it's using 33 multiplier, at 2 cores it's using 34 multiplier, and at 1 core it's using the maximum 35 multiplier. Okay, so 1 core it's like 3.6 with my approach, because I additionally added 200 megahertz, guys, by the way, to this CPU through some cheating overclock, not through the multiplier but through the BCLK clock. BCLK and stock on the CPU 100 megahertz times multiplier is equal the frequency per core, but I increased by 6 megahertz on this BCLK. Instead of 100 megahertz I'm using 106 megahertz, and times right now 33 should be pretty much if I would be running 100 megahertz times 33, it should be 3.3 gigahertz or 3300 megahertz per each core, but it's 3500 megahertz. So as you can see, I improved by 200 megahertz by this additional just 6 megahertz additional through the BCLK. Okay, if you're going to go above 6 megahertz additional on the BCLK, the whole system will be freezing on you and blue screen. So the maximum what you can achieve with the CPU, 6 additional megahertz on the BCLK. So instead of 100 megahertz, I'm running 106 megahertz, and pretty much on 99% of the highly overclockable motherboards, it will be scenario. Only for one ASUS you can strip the BCLK frequency and you can try 115 megahertz. Okay, but as again, sometimes it's I'm not sure if it's stable or not 100%, but this scenario that you can see right now completely 100% stable. Also, this CPU is not a great with the DDR3 memory. It's very peaky and doesn't want to go stable on DDR3 above 1200 megahertz. Keep that in mind. Just like the Xeon E5-2697 series V3 is not stable above 1200 megahertz on the DDR4, and this one is peaky with DDR3, especially when we're talking Xeons, which is the top dog, so the maximum CPU cores count. Guys, as again I told you, this video is not going to be fast, this video will be slow, so grab yourself a favorite drink. As again, water with the lemon, if you don't have a tea, is great, but with the tea just to bring some taste, and it's gonna clean up your body. It's amazing. This is exactly what I'm drinking right now, and try it for 2 months and see the results. Every day try to drink the organic green tea. I advise you the organic green tea such as raspberry before the bed, like 3 hours before the bed, with the lemon, half of the lemon. Try it, but put the lemon in the tea when it's not so hot, when it's kind of warm, ready to drink. Do not put the lemon and pour the tea with the hot water. This is incorrect. This means that you didn't study the physics and chemistry in the high school. As again, depends what kind of high school you went. You know, regular high school probably didn't, but if you went to a special high school, you probably did. Anyway, so this is what we were running, right? This is what it is. Let me a little bit drive through the town, and then I'm going to shut it down, and I'm going to go ahead and do the 4-core 4 threads. But during the gameplay, we're not going to overload our CPU cores. Mostly it's going to stay way below 90%, but during the benchmarks it goes to 100% when you're using 3-core 3 threads. With 4-core 4 threads, it don't go to even 90%. Keep that in mind. Hopefully it makes sense. Okay guys, I'm coming in real time as again, so don't forget to smash that like button, guys. As again, this is the world's first 16K resolution render in GTA4, or 133 megapixel render in real time on just Titan RTX. And Titan RTX is the first video card that allows us, guys, to play this game at 16K resolution, or bench this game at 16K resolution, whatever you want to call it, because it has 24 gigabyte of the VRAM, which is the video RAM. So actually it's a little bit above than 24 gigabytes. It's going to be 24,648 megabytes, if I'm not mistaken, something like that. But when VRAM is you know, you pretty much getting above the limit of your VRAM. NVIDIA driver is so smart, it's going to offload some data from the VRAM into the system RAM, but it has the limit, and at some certain limit it can crash the game. If NVIDIA didn't offload some data from the VRAM into the system RAM, the game would crash when you're going to reach that limit. But you can go a little bit above that limit by about, I believe, 4,000, 5,000 megabytes above the limit of your VRAM. But when you're reaching above the limit of your VRAM, you're receiving slower FPS comparing to the video cards that are going to have the healthy VRAM amount, and your latency delay in terms of milliseconds is increasing as well. And we probably right now is increased offloading some data from the VRAM into the system RAM, because this game should consume below 10,000 megabytes of the system RAM, and it's consuming almost 12,000 megabytes of the system RAM. So I would assume we are offloading about 2,000 megabytes data from the VRAM into the system RAM, and even before we're reaching that maximum capacity of our VRAM on the video card. Why? Because NVIDIA drivers predict. So without the crashing the game. It's predict and it's already offloading. So I'll assume right now we are uploading based on the right top corner data, as you can see, updated every second. I believe that we are uploading pretty much the data is self-explanatory, not like those copycats. As you can see, we are uploading about 2000 megabytes or 2 gigabytes of data from the VRAM into the system RAM. So I'm pretty sure I think over here the VRAM utilization should be already 26 gigabytes. Okay, but for us to find out, it's going to be like in 2022 when they're going to release the video cards with 32 or 36 gigabytes of the VRAM. We're going to find out that. But as again, Titan RTX is the first video card that allow us to play this game at 16K resolution. Keep in mind, guys, that I'm going to record 12K resolution as well. This system that I'm playing right now is not my gaming PC for 2020. This system that I'm playing right now is my workstation, and I decided to go ahead and show you how on workstation that's pretty much designed for the 8K video encoding and 3ds Max rendering. I'm using a lot of 3ds Max that utilize above 100 cores at 100% without any problems. And when I'm doing the 8K video encoding through my FFmpeg++ application that I'm developing, it also utilizing 24 threads without any issues, and my FFmpeg++ application will utilize 140 CPU cores at 100%, so it's going to take the advantage. But I decided to go ahead and show you how on workstation you can play the games, and to prove you that the key for any system to play the games is the video card, and you wanna chip out on your CPUs and system RAM, but you wanna invest all that money towards as priority towards the video cards. And this is going to be pretty much the explanation. All right, but as again, this is not the gaming rig. On my gaming PC, I'm going to show you the video and 16K resolution as well. It's going to be Core i9 9900K overclock at 5.3 gigahertz. It's going to be also very special video for you to watch 16K resolution, and I believe the GTA4 supports SLI, and if this will be the case, if I will be able to enable the SLI, I will also show you on this workstation 2 Titan RTXs and SLI at 16K resolution and 2 Titan RTXs on my gaming rig as well. Plus, I will try to show you on this workstation 12K resolution, which will be 3 8K resolution monitors in vertical mode. So I'm going to use the width as height, which will be 12K resolution of those 3 8K resolution monitors, 8K resolution on this workstation, and 4K resolution on this workstation, just in case if you will build this workstation for your low budget all-in-one PC. And I purchased this CPU, guys, in the beginning of 2020 for $129. So why I did it, pretty much I used this motherboard and I used the i7-4930K CPU back in 2013, 2014, all the way till 2016, and I sold my i7-4930K that was overclockable to 4.2 gigahertz, but it was only 6 cores. I sold it on eBay used like new in 2020 for $100, and I bought this CPU for $129. But this CPU has 24 threads or 24 virtual cores in Windows or Linux, and as workstation it's amazing. So I'm having advantage. This is exactly, you gotta be strategic. This is exactly why I did it. As you can see, everything is strategic. If you want to have money, you gotta apply some intelligence all the time. Poor people doesn't think so. They think that you know, people with the money, they're not smart enough, but it's completely opposite. They always thinking about saving every single penny all the time. This is why they kind of rich and with the money. And you gotta apply the same algorithm if you want to be person with the money, and if you want to experience a lot of things in life. Hopefully, guys, that makes sense. So look at this. This is without any modes. It's running completely vanilla, completely classic, original PC game, GTA4. Of course, you can apply some modes, but probably not at 16K resolution. And I definitely going to show you with the best modes. Go ahead and advise me the best possible modes for GTA4 that you would like to see. If Titan RTX will be able to run in SLI here, which is 2 Titan RTX video cards and I will go ahead and do it for you. As again, I will also test it with RTX 3090 and with the future video cards and future PCs. This is why we're benching it. So this is the reason of this video, just to show you the benchmark. Hopefully this makes sense. As you saw, guys, it's like 14 FPS, 13 FPS average. Don't forget to add 3-4 FPS at least to the FPS counter, because as again, I'm not recording this video with external recording device. I'm recording this video with NVIDIA Shadowplay in 8K resolution, and it consumes 4 FPS, which is amazing. NVIDIA Shadowplay is the best recording screen capture software, guys, out there. Believe me, because in 2009 I was developing my own video capture. It was called Morose Video Capture, but I couldn't achieve 4K resolution smooth as NVIDIA Shadowplay, so I stopped that development. But NVIDIA Shadowplay can go even above that, because it has the hardware acceleration on the video card, and that hardware acceleration is going to beat any software screen capture softwares out there, any competitors, because they don't have the hardware acceleration. Hardware acceleration will be always on top of any software acceleration screen capture softwares. Hopefully, guys, this makes sense. So you saw the VRAM utilization was below 24,000 megabytes, which is, well, very low. I'm not sure why, because when I'm using 4-core 4 threads, it's like 24,000 megabytes. And system RAM usage was below 12,000 megabytes, but also very high. And Titan RTX is overclocked, by the way, right now. 2,000 megahertz additional on the VRAM, otherwise it would be running 14,000 megahertz on the VRAM stock frequency. And it's GDR6 Samsung, same VRAM as on the RTX 2080 Ti, and 100 megahertz additional on the GPU as overclocked. Okay, I'm going to show you guys in the end of this video. So as you can see, we just reached 91%. So sometimes when you're reaching that above 90% or 90% during your gameplay, this is a clear reason that you need to add additional 2 threads or 1 thread. Start with 1 thread, and it better be a physical, not the logical through the hyper-threading technology, but the physical. Okay, let me go ahead and, guys, reboot the game now, and I'm going to reboot the computer, and I'm going to add 1 more physical core. Okay, I will see you guys in a second. As again, for those haters, for those naysayers, this is how you're rocking this. Enjoy. Alright, I will see you guys in a second. And alright, guys, do we have any difference in the score? Let's go ahead and have a look. This is with the 4-core 4 threads for visual physical cores, not the virtual. 27.43, as you can see, same presets, but we lowered our frequency, as you can see at the right top corner, by 100 megahertz. So instead of 3.5 gigahertz per core, we're running 3.4 gigahertz per core, or 3400 megahertz versus the 3500 megahertz at the right top. So lowered by 100 megahertz, and pretty much almost the same even when we were bottlenecking, but we're compensating pretty much by 100 megahertz almost, as you can see. Over here, within bottlenecking, we didn't reach never above 95%, but not a big improvement as well. Alright, let's go ahead and see how the 4-core 4 threads will be in the game right now. And it's going to be, as again, the static animation that can be used as a benchmark, where we're going to arrive to United States. As again, this is a very special video, guys. 16K resolution, world's first GTA4. So don't forget to smash that like button, guys. Share it with your friends and positive comments. And I'm going to record it on my gaming system. It's not easy to do this stuff, guys. It requires a lot of skills, not only the programming skills, but also the approach, how to do that, as you can see, and the hardware. A lot of money invested as the hardware. So go ahead and visit my sponsors, smash my sponsors, and support me by that, guys, and with your like as well. So 21 FPS, 20 FPS, as you can see. Look at how little our overall CPU utilization now. We're going to reach once during the benchmark at 90% with the 4 core 4 threads, but pretty much when it's going to be like a big shooting scene and stuff like that. But pretty much, as you can see, during the regular gameplay, it's going to be Gucci 4 core 4 threads. But to be honestly, this game requires 6 core 6 threads without bottlenecking through the CPU cores. If you're playing 4K resolution and above, like 8K resolution, but above 8K resolution, 4 core 4 threads will be Gucci, guys, as you can see. But if you're playing 1080p, I would say even this game probably will require 8 core 8 threads without the bottlenecking, or just 4 cores with the hyper threading technology, which is 8 threads. But as again, you're going to lose a lot of FPS through the hyper threading technology, logical cores processing. Keep that in mind. Even if 9 gen, which is my gaming rig, i9-9900K, the logical cores through the hyper threading technology improved, and now it's not 3.5, it's like 2.1. Logical cores is equal 1 physical core in 9 gen, and in 10 gen I would say it's going to be 2 cores equal 1 physical core. But it's still not good enough. As you can see, we're still going to receive that latency delay, and we're going to lose some FPS. Not bad, guys. Cannot wait to test it. This is maxed out visuals. Cannot wait to test it as medium visuals, and the low visuals is probably going to be Gucci. Okay. This game is beautiful, guys, especially when you're going to put some modes on it. If the SLI will be supported, I will probably record 12K resolution with a 3 8K resolution display on a native single 8K resolution through the DSR to 3 8K resolution displays, which is 12K resolution with the modes, guys. It's going to be an amazing video, and I'm probably going to use my gaming rig for that, and I think the FPS will be gorgeous. With the modes, this game is on another level. With the modes, this game is almost as GTA4 in terms of the visuals. Because as you can see, the Titan RTX is thermal throttling a little bit, so it's supposed to run above 2000 MHz on the GPU, but it's not. So if your Titan RTX is going to be on water, you're most definitely going to be increased by about 3 FPS as well. It's going to be just like additional overclock, additional 10% at least of boost, but it's not going to be like 20% boost. Keep that in mind. So 10% boost for sure, but below 20% boost if you're gonna set them on water. And to set them on custom loop, it's going to cost you at least like $400 and $500, but as minimum as $400. But to use like a ghetto water cooling, you're still going to invest around $250. So if 10% was $250, I would say probably not. Keep that money, save this money, and invest them towards the newer generation of the video cards. It's going to be like a quarter price of the newer generation of the video cards that's going to outperform of the Titan RTX. Keep that in mind. The great that you can receive the boost through the software overclocking, which is 10%, which is amazing. Look at my VRAM utilization, guys, above 24,000 megabytes, so above 24 gigabytes of the video RAM, which is the VRAM utilization, and the system RAM utilization below 13,000 megabytes. CPU utilization is great. We're not gonna see during the gameplay above 80% at all. Means that we're Gucci. Not even above 70%. Okay. So again, guys, you want to keep your eye at the right top corner. for the display information system, and be strategic. Do your own analysis, and this is going to be the best. Alright, so this is what's up. I'm going to go ahead and quit now, and I will let me real quick go ahead, guys, and show you again for those naysayers. So pretty much maxed out. Okay, this is how we were running. So right now I'm going to go ahead, guys, and quit it, and I will see you in a second when I'm going to go ahead and lower the visuals. Back, and I rebooted the game. First lowered the visuals, then rebooted the game. So pretty much this is going to be a medium preset, but still textures will be maxed out. So pretty much it's hard to tell the difference between the maximum visuals and this kind of medium kind of maximum visual preset. But during the benchmark I saw my CPU reach the 95% for maybe 1 second once, and because we lowered the visuals, and there is more stress now on CPU. The higher the visuals, more stress on the GPU. The lower the visuals, more stress on the CPU. But this is the results, guys. 26.75 increased by just a little bit. Let's go ahead and run the game now. But as you can see, the VRAM utilization lowered down itself from 24,000, above 24,000 megabytes, which is about 24 gigabytes on our VRAM, down like to mid-ish 23,000 megabytes. And the system RAM is also decreased, as you can see, from 11,000, above 11,000 megabytes to like mid-ish 10,000 megabytes. So the NVIDIA driver is not panicking any longer like it was before. Yes, definitely 26, 25. We increase in terms of our FPS by a little bit. Cannot wait to run the low, but still with the textures at high, because what's the point to play the game with the blurred out textures, artificially blurred out textures? You better run them at the maximum possible visuals that they design to be in the game. And so I'm going to, next preset will be lowest possible settings, but the texture is still at high, just like right now. Textures at high and everything else at medium, and then just everything at low, and we're going to find out if we can play above 30 FPS the GTA4 on a single Titan RTX or not. Cannot wait, guys, to see the two Titan RTXs and SLI, if I'm going to make the SLI working in this game, and if I will do, I will share with you over the SLIready.com, one of my new projects that's going to be dedicated to show you how to enable the SLI in PC games, and especially in the PC games that didn't support the SLI at the from the developers, but I'm going to show you how to enable it with an easy to follow language. Keep that in mind. The game is beautiful, guys, as you can see. Especially with the mods, it's going to be amazing. So this game aged well, guys, as you can see. Even if the characters, as you can see, kind of low 3D meshes, 3D models, but still nice in terms of the polygons count. Kind of low topology here. With the modes, it's going to be on another level. The game has the atmosphere, which is nice. It's believable, nice atmosphere and addiction. So it's a great game. You will be, guys, enjoying at 16K resolution, and pretty much 16K resolution I'm predicting will be 2027, just when the PC gaming will die and everybody will be switching to iOS devices and like iPhones and iPads. So at convenient in your pocket, or a little device that can last you for a long time, quiet, not overheating. The life cycle is over 5 years. this is going to be way to go, guys, and it can play any games at maximum settings, which is the best. And I believe in 2027 Apple will release A18 Bionic chip, and it's going to support like 16 CPU cores, 32 GPU cores, and around 64 neural cores. And this is going to be the era when the PC gaming and console gaming will be no more, because pretty much you can connect the HDMI dongle or some USB C dongle and or some other newer technologies to your smart TV, or to play even on your smart TV without any cables, through the wireless, through the Bluetooth, and enjoy it, guys. Just broadcasting, but without any compression, at the maximum possible quality. Probably you want to use the dongle, some cables, but still it's a device that can be in your pocket. You can connect the gamepad to it, and you can enjoy, guys. It's the way to go. That's why I believe that iOS gaming will survive, and I'm going to develop my own iOS game in 2021, and I'm going to also show you a lot of gameplays on iOS devices. Keep that in mind. Did you see that it was like a kind of freezing out for 1 second, and why it happened? As you can see, the VRAM utilization just went south, means that it went above 24,000 megabytes, and this is what was the moment, I believe, when NVIDIA drivers decided, you know what, I'm going to go ahead and upload some data into the system RAM. And of course, system RAM is so slow as DDR3, even in quad channel, versus the GDR6. It's just such a slow, because GDR6 is 16,000 megahertz and DDR3 is only 1,130 megahertz. DDR4 or DDR5 also not going to be enough here. Imagine the fastest possible DDR4 in 2020 is 5,100 megahertz, and GDR6 is 3 times faster than that. So means that you're going to see the deep in terms of latency delay and in terms of the FPS for sure. There's no magic, everything is logic, guys, over here. Okay, so you saw the benchmark, and every single benchmark results that I'm showing to you guys was done without the shadow play recording. Keep that in mind. It's going to be a raw data. And right now you saw with the shadow play recording, as again you want to add about 3-4 FPS to the FPS counter. Actually, I can play it like this. It feels so great in this game, especially if you're going to use the gamepad. It's going to be even smoother, the FPS. If I'm going to hide the FPS counter, you're probably not going to tell that my FPS is horrible. I don't think so. Look at this, it's playable, not so bad. I would play this game like that. Maybe when you're going to shoot during this game, it's not going to be okay, but when you're driving, it's most definitely okay. Let me show you guys some burnouts here, some volumetric particles. Okay, so what I'm gonna do now, guys, I'm going to go ahead and do everything at low possible settings, but still textures will be at high. Let me real quick and show it to you. This is what's up, this is how we were running. Okay, so right now I'm going to pretty much lower everything down, and I will see you in a few seconds. Alright guys, so as you can see, I'm done. Everything set at lowest possible presets, except the textures are still at high, which is the maximum possible visuals. And of course 16K resolution. Why you want to bring the textures too low? Doesn't make no sense. Okay, so let's go ahead and have a look. As again, the benchmark stats are without the recording, and right now with the recording. So you can see Titan RTX starting at 2010 megahertz, but then it's going to thermal throttle itself to below 1900 megahertz. So if you're going to use the water cooling on it, even the ghetto water cooling, your Titan RTX frequency will be 10, I would say if you're going to overclock by 100 megahertz additional, as I just did under the MSI Afterburner, it's going to stay at 2040 megahertz, but not going to go below 2000 megahertz, and increase in terms of the FPS will be additional around 3 FPS for sure. So I would say additional 10% for sure, but it's not going to be like 20 or 25% just because the water cooling. So still not bad, guys. Look at this, everything at lowest possible visuals except the textures, and the game's still looking great, almost the same as it was at maximum possible visuals. But as you can see, our VRAM utilization now went below 23,000 megabytes at the right top, and our system RAM utilization is above 11,000 megabytes, but it's lowering itself. And yeah, at least we have almost healthy VRAM utilization. I'm pretty sure that we're still overloading about 1000 megabytes into the system RAM by the NVIDIA driver, or about 1 gigabytes. But right now, at least right now, it's breathing pretty well. It doesn't have that kind of hiccups sometimes, as you saw during the maximum possible visuals. It was like a hiccups in a couple times. I didn't see them any longer. As again, cannot wait to test this on my gaming PC with the i9-9900K and the Titan RTX, and if it's going to be possible, 2 Titan RTXs in SLI, it's probably going to be like wow. At least over here, if 2 Titan RTX is probably going to scale around 1.9 times at least, and pretty much we're going to be 40 FPS average with this preset, which is nice. 40 FPS is not 30, 40 FPS is almost comfortable, guys. I mean comfortable playable status. Guys, I'm falling asleep. Don't forget to smash that like button. But I was so impressed because the GTA4 can run 16K resolution. This is unbelievable. This is, as again, the first video card that allow us to do a Titan X Maxwell GPU architecture, or Titan XPs couldn't handle it because the VRAM capacity. It probably could handle it because the GPU, especially Titan XP GPU performance, but probably over here we would be on Titan XP around like 16 FPS or 15 FPS by 5 FPS lower, or even by 7 FPS lower, but still will be probably benchable. But it's not allowing us to do so because the VRAM capacity is only 12,000 megabytes, which is I believe 12,600 something megabytes, or 12 gigabytes. And as you can see, we're double, almost double of that. So also cannot wait to test this game with the video card with 32 gigs. I think this game takes around 27 gigabytes at maxed out 16K resolution, but we're going to find out in 2022 if I were correct or not based on my calculations. As we can see, we don't see any more reflections on the car. It's kinda almost like a matte paint color. But when I was running maxed out visuals, it was kinda reflecting surface material on the 3D meshes of the car and doors and stuff. Still textures at high, as you can see, so detailed the headlights. Okay, let's go ahead and have a look. Still below 23,000 megabytes and 2425. Look at this. Wow, now with the gamepad, I'm pretty sure with the gamepad is going to be playable, especially if you're going to hide the FPS stats from the gamer. I think you're gonna think that this is like a 40 FPS. I'm sorry, lady, you still alive? Guys, I will try to release this video on the December 21st 2020, just before the ending of the 2020. I will compress this video tonight, compress it in a higher compression algorithm, and a little bit lower the bitrate value, but still at very high quality for you. So please watch this video on 8K resolution monitor and switch to 8K resolution in your YouTube player. Nice, pretty much beautiful, as you can see. And we can drift in this game and do all kind of different things. Yeah, the physics in this game, and I believe it's using the physics as well. Physics and physics, if I'm not mistaken, in this particular game. I think GTA4 was using the physics as well when it was released. When it was released, it was time of the PS3, Sony PlayStation 3. Hi guys, showed you everything. I'm going to go ahead and let me show you the presets. Here's the presets. So I'm going to go ahead and close the game and show you what kind of system I was running today. Let's go ahead and do that. Hopefully it's not going to freeze up on us. It shouldn't. Yep, it didn't. Nice. So let me real quick go ahead and show you. First of all, let me show you what date of the recording it was accomplished. See that? 12/29/2020. So 2 days before the year is ended. Actually 1 day. Right here, 4 AM guys. Don't forget to smash that like button. As you can see, a lot of time, money, energy is invested. Visit my sponsors, guys. Okay. So this is the presets. As you can see, OpenCL API, bench RGB, GPU, and the CPU under the IDA64 GPU benchmark. So you can compare how the this TU102 GPU by NVIDIA, which is the Turing GPU architecture by NVIDIA in this Titan RTX, compares versus our CPU. But as again, CPU was only running full core 4 threads, but it was overclocked at 3.4 gigahertz. And Titan RTX and Titan RTX GPU was running completely stock. It wasn't overclocked when I benched that, and it was without the recording. Keep that in mind. The benchmarks was without the recording during this video. So this is how quad channel scored. In terms of read, write, and copy, values will be equal to DDR4 2133 MHz CL14. Okay, which is impressive. And this is 1130 megahertz on a DDR3, but quad channel, which is 256-bit. Theoretically, it should be 2 times faster as dual channel, which is 128-bit, but it's not. It's 1.5, 1.4 times faster than dual channel. Same technology of the system RAM. Okay, and as again, this was my overclock over here. And this is how I was running, guys, for core 4 threads. As you can see, BCLK bus speed, as you can see, I told you, was overclocked from 100 megahertz to 106 megahertz, additional 6 megahertz. Give us that boost of 200 megahertz additional, no matter what kind of scenario we're running, and no matter what kind of turbo boost and how many cores. Okay, there's a little cheating. We cannot overclock through the multiplier, but we can boost up by 200 megahertz through the BCLK frequency. times 16. So this is our Titan RTX was running PCI Express 3.0 times 16 with F20 BIOS, March 19, 2014, from a gigabyte official BIOS. This is the only BIOS that's supporting this CPU, guys. So you want to flash the BIOS before you're going to install the CPU, otherwise it's not going to post. And this is version Gigabyte X79 UD3, which is ultra durable 3, but version 1.1. They have two versions, version 1.0 and versions 1.1. Make sure when you're going to download the driver, you're downloading the right driver. So 565 megahertz times 2, 1130 megahertz, CL9. Okay. CL7 is unstable. So, and above this frequency, 1130 megahertz, it's also unstable. I can push it to 1400 megahertz and boot up into the Windows, but after 30-40 minutes it's going to crash. But this is rock solid, guys, stable. So as you can see, overclocked memory 8000 megahertz times 2, 16,000 megahertz. But when it's going to run stock, it's going to be 7,000 megahertz. And this is how it's scored. 4 times on a 4-core 4 threads, which is excellent CPU score result, guys, for the multi-thread ratio. Usually it's like 3.97, 3.87. This is excellent, and I believe this is due that level 3rd cache, which is 30 megabytes, shared on the 4-core 4 threads instead of 24 threads. Keep that in mind. Okay, let me go ahead and lower the value of the Titan RTX and show you what overclock did us. First, let me open up the GPU Z. Here we go. So I'm going to go ahead and bring the Titan RTX to stock frequencies, and you're gonna see that pixel fill rate will decrease, textual fill rate will decrease, and the bandwidth will decrease by a lot. Let me go ahead and do it. And over here, memory will decrease to 7,000 megahertz as well. Boom! I just brought it back to a stock, and as again, this dual fan NVIDIA design Titan RTX, completely stock without any modifications. And also I was using the NVIDIA thermal compound paste. I did not use the liquid metal thermal compound paste, otherwise we would probably run a little bit higher frequencies. And as again, this is a GPU benchmark when we compared CPU versus GPU under the OpenCL. The Titan RTX was running completely stock, guys. Okay, as you can see, it decreased pixel fill rate, textual fill rate, and bandwidth. Okay, that's it, guys. Let me also show you something. So this is my system, as again in the middle, and this is the my gaming rig in the right top corner. Let me show you. As you can see, desktop is set to 16K resolution as well, but let me show you my desktop resolution for those naysayers. And it's pretty much 16K resolution, 133 megapixels, and 100% scale. Okay, this is how it is. Alright, guys, well, thank you so much for watching. Don't forget to smash that like button, subscribe, positive comments, guys, share it with your friends, and I will see you guys in the next videos. Right now I'm putting in the video description or in the video comments some great videos for you to check out. Do not miss them. It's going to be interesting videos, and yeah, hopefully you learned a lot of information as a beginner or as advanced user, as PC overclocker, PC enthusiast. A lot of things was discussed, and you're gonna build the best PC in the future. Alright, as again, I play 4K, AK, I play AK, I play 16K, or UHD King was with you today. Have a great day, stay safe, till the next time.